Good day to all of you. Today's topic for M.SC final students is conventional tubes limitations. Before that topic, conventional tubes limitations or limitations of conventional tubes, before that we just go through characteristic features of microwaves. We know that the microwaves are small size of wavelengths waves from 1 centimeter to 30 centimeter. Okay, so the main characteristic feature of microwaves originates from its size. That means its small size in relation to sizes of components or devices commonly used. Okay, so it depends upon the size of the microwaves. Number 1 point, since the wavelength are small, because we know that the wavelength is small, the phase varies rapidly with distance. Because wavelength is small, hence phase changes rapidly with the distance. Consequently, the techniques of circuit analysis and design of measurements and of power generation and amplification at these frequencies are distinct from those at lower frequencies. Because wavelengths are small, frequencies are higher, hence their circuit analysis, design and power generation and amplifications are different from lower frequency. For dealing with these small wavelengths, methods of circuit representation and analysis need to modify. The methods we are opting for circuit representation and analysis should be modified according to these wavelength ranges. The phase difference caused by the interconnection between various components. Phase difference caused, how phase difference relevant to the interconnection between various components or various points of a single component, and these are not negligible. These affect the such kind of analysis. Number 2. Consequently, analysis based on Kirchhoff's law and voltage current concept are not adequate to decide the circuit behavior at microwaves. If we are taking the circuits at microwave frequencies and we want to analyze the circuit at microwave frequencies, then the Kirchhoff's laws and voltage current concept are not adequate to describe such kind of circuits, because these laws cannot be applied at microwave frequencies. It is necessary to analyze the circuit or the component in terms of electric and magnetic field associated with it. That means what kind of theories or what kind of analysis is there, we must analyze the circuit of components in terms of electric and magnetic fields which are associated with it. We are using here electromagnetic theory. That means electromagnetic engineering or applied electromagnetics is necessary for such kind of circuit analysis. A background of electromagnetic theory is prerequisite for understanding microwaves. That means you must know about the background of electromagnetic theory, which you already studied in your M.SC previous electrodynamics paper. So somewhere necessary you can understand from that paper. Measurements are carried out in terms of field, amplitudes. How measurements carried in terms of field amplitudes, phase differences and powers carried by the waves. A very commonly used method of microwave measurements is based on the study of a standing wave pattern formed along the line. This is a very common method that is used in microwaves, a stationary wave pattern formed along the line because of the interference of incident and reflected waves. What is the reason? Interference between incident and reflected waves. Ratio of the amplitudes and phase relationship between incident and reflected waves tell us about impedance characteristics. What ratio of amplitudes and phase relations between incident and reflected waves tell us? Impedance characteristics of the components. Impedance characteristics of the components causing the reflection. Microwave circuit components also have a different look. They have different look other than simply used in circuit components. Okay. So what kind of look is there? Circuit elements, use of lumped elements at microwave frequencies. Use of lumped elements at microwave frequencies becomes difficult because of small wavelengths involved. For realizing the lumped behavior of a capacitor. Lumped behavior of a capacitor, an inductor or a resistor, the component size must be much smaller than the wavelength. If we are using inductor or resistor, the component size must be much smaller than the wavelength. Because of this reason, microwave systems employ distributed circuit elements. Distributed circuit elements very often. Number 7. Microwave elements are made up of small sections of transmission lines and waveguides. Microwave elements are made up of small sections of transmission lines and waveguides. These are necessary topics to understand by you what is transmission line and what are waveguides. So go through these topics. Okay. For example, a quarter wavelength section of a transmission line is used. There is an example given that if a quarter wavelength section of a transmission line is used, an impedance transform which kind of use? Impedance transform. A half wavelength section on the other hand constitute a resonant circuit. Quarter wavelength is used as impedance transform and half wavelength section is used as resonant circuit in place of LC resonator. LC resonator used in conventional electronics. Okay, and half wavelength section is used in place of that for resonant circuit for microwaves. Use of miniature lumped elements. What kind of use? Use of miniature lumped elements. Very small size elements at microwave frequencies has been made possible by advancement in microelectronics technology. What is used? In which technology? Microelectronics technology, where miniature lumped elements are used. Microelectronics technology techniques allow us to fabricate inductors, capacitors, and resistors that are about a millimeter or 2 in size, or 2 in size much smaller than small wavelengths. Very small size of inductors, capacitors, and resistors are used that are of in the range of millimeter or smaller than, which can be used at microwave frequencies or smaller wavelengths for microelectronics technology. You can understand, we can understand that you know the figure of this is a triode, anode, grid, and cathode. Okay, a simple example is shown here. This loading is due to dissipation of power at the grid. This loading is due to dissipation of power at the grid. Dissipation of the power at the grid. The effect of loading is such that noise in the circuit increases. The effect of loading is such kind of that noise in the circuit increases. To minimize this effect, the distance between electrodes is to be reduced. The distance between electrodes are adjusted or reduced, and high voltage must be applied. This will increase the inter-electrode capacitor, because due to this inter-electrode capacitor increases. And here in this figure, a transit time is shown, that how transit time is increases. Okay, if we readjust the distance between the electrodes, okay, here what you are seeing in this figure, this is TT time, transit time, and here this is T, and this TT is greater than T. Okay, so such kind of thing can be used for adjusting the distance, and by using such kind of thing, reduced or high voltage must be applicable, and due to this inter electrode capacitor increases. So in this lecture we try to understand the things that how circuit analysis used at microwave frequencies. So what we learned, that at microwave frequencies, due to its smaller wavelength, simple circuit analysis is cannot be used, like Kirchhoff's laws and voltage current law. At that place you must go for electric and magnetic fields components. That means electromagnetic engineering must be used for such kind of analysis. And now in next lecture we try to understand the frequency limitations of conventional tubes. Okay, thanks to all of you.